Okay, greetings. This is VK7MO, the club station of the Radio and Electronics Association of Southern Tasmania with our ATV Experimenters Night, and we have a huge number of viewers streaming in, and we've even got our studio audience for a detective story.
Yes.
And I've got Rex Moncur VK7 Mike Oscar sitting next to me, and I will throw to him and we'll learn about these strange signals that, sorry, I keep remembering, it's in a different place now, isn't it?
Right.
And I'm looking forward to finding out what these strange artefacts were on your 10 gig signal. So across to you, Rex.
Well, thank you, Justin. Do you need, oh, I see, the camera's coming across. The new studio is doing its stuff. And yeah, welcome to all our guests. I see we have Charlie and Petra in the UK. We've got Derek over in Western Australia. David, 3HZ in Melbourne,
And many others.
and many others. So thank you all for coming on. This is essentially an addition to the talk I gave back early January about the world record on 10 gigs. Back early February, well, around about the 9th and 10th of February, I tried with Derek to extend it. We weren't successful in doing that, but we got a lot of interesting results, which I think are worth talking about. So, let me just go. So the original world record was, Derek was over in Western Australia, over here, and that was to me at Cape Portland. This time Derek was, at that time was at Torbay Hill, and this time Derek went a bit further west so we could try and extend the record by about another 64 kilometres. We did have a couple of other options that we were looking at. One was Windy Harbour, but unfortunately there were bushfires such that poor old Windy Harbour had to be evacuated and no one was going to let us near the place. And the other option was right over here at Augusta. The problem with Augusta is the path goes across land, and I don't think we're quite up to trying things out across land yet to see whether that's possible. So we went for Peaceful Bay. And these are the stations who are involved. We had Derek at Peaceful Bay. I was here at Cape Portland. 5DK a bit northwest of Mount Gambier. 5KK up in the Adelaide Hills, and David 3HZ was also involved and was in some ways the cause of all my worries, because he monitored my signal on 70 centimetres and saw some artefacts that worried me, and we will talk about them later. Now, Peaceful Bay, Derek was set up on both 10 gigs with this 60 centimetre dish and on 70 centimetres, and you can see he's beaming towards me, I think, at the moment, and he's over the water, so this was a fully over water path. And I was here at Cape Portland. There's a wind farm, and I was beaming out in this direction on 10 gigs. Now, this was what the Hepburn chart looked like at the time of the world record back on the 5th of January, and it wasn't all that spectacular. It went for a nice yellow orange bit here, but down to green and blue and a bit of green and a little bit of yellow, and almost dropped out, and yet it worked. So this time things looked a lot better on the night between the 9th and the 11th of February. and I was expecting big things, but they didn't happen. And we might be able to explain part of the reason why. Now, we'll just compare those two again. There's this one which is interesting but not spectacular, which worked, and this one didn't work. Now, the difference is when you look at the actual Weather Bureau mean sea level chart, are that there is a low pressure trough across the middle of the path. And that probably is through about here, but doesn't actually show up on the Hepburn charts. And I think that's because the Hepburn charts are based on global models that average signals, not average signals out, average the data out, whereas the fine resolution data that you get from radiosondes and others sources allow you to fill in things like troughs and get find out what might be going on the path. So the first conclusion is, don't always trust Hepburn. Have a look at the mean sea level charts and see if there's anything that might be stopping the signal along the way. The problem with my theory is that we had David 5KK up here, and he was also beaming through this trough, and he got through. And in fact, he got through on SSB on 10 gigs.
What sort of signal is that?
5 and 1, 5 and 3 and 1.
Okay.
And that's the first time David's worked across there on SSB. He's done it about 5 times now on JT4.
Okay.
And this is a bit further, another 64 kilometres. So I don't know that we can draw enormous conclusions about these troughs. But the signal certainly didn't get to me, although on 432 I could what's going on that I don't know about.
No.
You're playing games. Okay. The signal didn't get to me on 10 gigs, saw absolutely nothing, but on 432 I actually got quite good decodable signals from Derek, suggesting that wasn't that far off, but Derek couldn't actually decode me. And
So what were you using as an antenna on 432? Just
about
a-
a 14 element Yagi,
Okay.
or
Okay.
maybe, no, 22 element Yagi.
Okay.
It's an antenna that I use for EME
Right.
when I'm portable. It's just a single Yagi, but I have got the preamp sitting right on the dipole.
Okay.
And I think probably the main reason Derek didn't copy me is he was feeding he didn't have a preamp. He had a what are these, FT897 or something like
Yeah.
that, which probably doesn't have a really good low noise preamp at 432, and he was feeding it through a PA that had about 3 dB loss, plus another 8 metres of cable to the antenna. So that possibly was the reason, but in part the signal was coming in bursts of 20 seconds or so.
So what, slow fade or?
Slow fade, you see.
Okay.
And one of the problems, which we'll go into in a little bit more, is that JT4 doesn't have a lot of error correction like JT65 has. And we think when you get this fading that's only lasts 20 seconds or so, JT4's not able to fill in the gaps.
Okay.
JT65 potentially should, and that's one of the things we'll talk about.
Okay.
Now we tried again on the 11th of February, and this time I had massive signals across to the VK5s. SSB 5 and 9 to 5DK. And 5 and 5 to 5KK, and that's over 1,000 kilometres on 10 gigs.
Doesn't get much better than that.
But absolutely nothing across to Western Australia,
Okay.
not even on 432. 5KK and 60Z got very close to completing on JT4 on 430 on 10 gigs, but the bottom fell out just before they could get, I think, the final RRR that they needed. So again, there was propagation around for 10 gigs, not to me, but certainly across to 5KK. Subsequently, David 5KK has found out the reason he wasn't able to complete. His PA, which is nominally 10 watts, had dropped off to being about 1 watt somewhere during this exercise.
Yeah.
And when I look at the files that 5DK received from Derek, they were pretty good. I mean, they were good copy -14s
Ooh, okay.
on JT4. So I think if it wasn't for the little equipment hiccup, they would have easily completed.
Yeah.
At least on JT, probably not on, well, certainly not on SSB. On the 11th of February. And for my case, I copied 5DK and 5AKK, 5 and 9 on 70 centimetres, so there was massive propagation here. Now you can see there's a cold front by this time, has just gone past where I was operating here. And the literature talks about post-frontal ducts. So I think these massive strong signals that I was getting across to VK5 was something to do with this.
Was it along the front?
Along the front.
Okay. Cool.
But while the front was helping me that way, I think it was just cutting me off completely to Western Australia.
Okay.
And the front had gone sufficiently fast past 5KK up here in Adelaide that
It didn't affect his signals.
It-
Yeah.
so
Okay.
I guess my conclusion about all this is there's a lot more information than is on a Hepburn chart if you can read the mean sea level charts as well
Yeah. Okay.
to understand what's going on. I also need to collect the Hepburn charts I think they come out every 6 hours, but once the day has passed, you lose them all. They're not available in archives, so in future I've got to collect all the Hepburn charts and all the mean sea level charts so I can analyse these things in depth. But there's certainly some interesting stuff here.
Okay.
And I should say 5KK's contact on SSB with 60Z, that was over the additional distance, so that was a very significant contact. In fact, the second longest 10 gig contact between VK5 and VK6, the other one being the one on the 5th of January where 5DK worked from near Mount Gambier. So some interesting things were happening, even though we weren't successful on the on 10 gigs in extending the distance. Now, one of the things that started to worry me when I found that I didn't have enough error correction to cope with these short bursts of signals was whether it would be possible to go to a JT65 to get the advantage of the extra error correction. And to understand that, JT65 works in a much narrower bandwidth, so we had to have a signal that was not spread nearly so much. one of the advantages of JT4 is it starts looking at 4.4 hertz bandwidth, and if it doesn't decode at that, it doubles it, and it doubles it, and doubles it out to about 300 hertz. Unfortunately, JT65 doesn't have that sort of capability, and of the three modes, it starts off at JT65 at 2.7 hertz, B at 5.4 hertz, and C at 10.8 hertz. I was thinking, well, even the 10.8 hertz might be useful. So I did a series of tests on Spectrum Lab looking at the spreading of the ducted signals. And the reality is, most of the time, they are not spread more than about 1 hertz.
So you can use the A.
You can potentially use the A. There are a few results that are worse, and just what caused them, I'm not sure, but if occasionally you get a bad one, doesn't really matter, because the advantage of the A is you pick up 3 dB on JT4, and you also have more error correction to cope with the signal. In this case, you can see that this was data from the 5th of January when we did the original record, and you can see these are 10 dB steps, so even about 40 dB down, the signal is still narrow enough to use JT65A. And it's interesting that Derry's signal, this was the best one I could find, was at that time, or once, was something like about 50 dB above the noise in 30 hertz bandwidth. Okay, so we went on.
That's an interesting.
That is an interesting finding. Now, of course, I discussed this with my friend David HZ, who said is on. He said, as he usually does, find something that I haven't thought of.
On you, David.
And he says, is this spreading due to the phase noise on your receiver, the 1.1 hertz? So I did a test just in my lounge room between a receiver setup and a SIGGEN that was GPS locked. And I got this red curve. Now 10 dB down, it's about 1.5 hertz wide. So that was essentially saying to me, I've got 1.5 hertz wide even without ducting propagation. So the propagation is not spreading the signal
very much at all.
Very much at all. Now, one of the reasons we use JT4 is for all the work David and I have done up to now, we've been using troposcatter. And troposcatter scatters from little particles that are moving in the atmosphere and cause shifting and spreading of your signal. But it seems like tropoducting doesn't spread your signal. Now that red curve
At 10 gigs.
At 10 gigs. Well, I suspect if it doesn't spread it at 10 gigs, it probably doesn't spread it at 2 meters either for ducting. Because certainly on troposcatter, the spreading of the signal is much worse at 10 gigs than it is on lower frequencies. I mean, I think spreading is a function of frequency. It's the Doppler shift of
and particle size
and wind speed and,
yep.
and so forth. Then it occurred to me, what was causing this spreading? Was it phase noise? And it occurred to me that I should run both my receiver and my signal generator from the same GPS so that the GPS was not influencing it. And then I got this peculiar yellow pattern. And that said that at least for about the first 30 dB, I had no phase noise whatsoever. I mean, it was down at about 50 millihertz. Oh, well, 10 dB down at 50 millihertz, and it might have been 100 millihertz of spreading at 30 dB down. Now, why it then sort of moved into this other sort of pattern, I can't explain, but the reality is, if it's more than 10 dB down, it doesn't matter a damn, because if signals are more than 10 dB above the noise, you're going to be able to decode them properly anyway. So there's still something I can't fully interpret about that. So I then had a look at what actually happens when you run two systems at 10 gigs of different GPSs. Now at the bottom here, you can see the frequency is drifting around to buggery, plus or minus half a hertz at 10 gigs.
Most people would find that acceptable, Rex.
But if I run them from both the same GPS, it's almost straight line. So most of that sort of 1 hertz spreading, I think, is due to just
instability between
two GPSs that I mean, they both look at different satellites in the sky, even though they're only, one was at the front of the house and one was the back of the house.
No, that's...
I mean, the reality is, plus or minus half a hertz is at 10 gigs is only 5 parts in 10 to the 11th, which the specification of that's about the specification of
a GPS.
the GPS, and if you put two GPSs together, you're going to get a bit more. So it looks like you have to live with this drift of
I can see you're disappointed.
Well, yeah, I wanted to get a better GPS. Out of interest, these horizontal lines are from there to there are about a minute. So, you know, half a hertz drift over a minute is the sort of things we've got to grapple with. Okay. So, if we look at modes for 10 gig ducting, JT4 does work automatically in variable bin widths anywhere from 4.4 up to 315 hertz, and it just chooses the best one to get a decode. So it's sort of the safest to use, but JT65 you actually have to choose which mode you're going to use, either A, B or C, and you have a bin width of either 2.7, 5.4 or 10 hertz, and you have to live with that. But it looks like for ducting you can live with that, providing the rest of your system's stable with good GPSs. Double oven, the ones that drifted half a hertz were both double oven GPSs. In 40 tests I did by gathering data between various stations that had been involved, the JT65A bin, which was at 10 dB, was only exceeded by 3 of the tests. I've written 3 dB, so I've made a little mistake. Oh, what have I? Oh, sorry. Exceeded 3 times. And of course you can gain 3 dB by using 65A over JT4, which is very valuable. Yep. And you also gain in having all the extra error correction. So we then went on. We looked at QSB, and at 10 gigs, this is the sort of QSB I had on the path to Derek when I did work him on the 5th. And that's only 20 seconds, so you can see there's the QSB is moving anything up to 20 dB over just a second or so. So obviously if you've got lots of error correction to fill in all those gaps, yep, that's well worthwhile. And now Derek told me that on 432 he was getting bursts of about 20 seconds or so that just weren't long enough to decode on JT4. And roughly 20 seconds to 1 second is about the ratio of the frequencies. So it looks like there's some sort of multiple signal going in the duct, which sometimes cancels itself or sometimes adds to itself, and the rate at which the cancellation occurs is roughly proportional to frequency, which is all useful to know and is also a nice argument for saying we want to keep all the error correction that we can to fill in these gaps. Derek, actually, just before I left, Derek sent me the actual files, and I'm starting to be not quite so sure about the 432. They might have just been too weak, but there's something to look at there.
Yeah.
So if we look at modes and sensitivity, essentially I've made this point now. We're better off to look at JT65A for ducting to gain this advantage. One of the advantages of JT4 is you can use single tones, which actually give you about 8 dB advantage in finding a signal compared to what you can decode. But in principle, there's no reason we can't get Joe Taylor to add single tone facilities to JT65. Single tones are also used for RRR and 73 that make it easier to complete the end of a difficult QSO.
I use it on HF, don't you? 65 HF.
You actually don't, you use double tones.
Oh, double tone, but it's 65 HF, 65 HF.
Yeah.
Oh, yeah.
But double tones cost you 3 dB.
Not too worried about
But
that.
the reason people use double tones is that they're not stable. But if you're stable, you can measure your frequency on a single tone.
But it's amazing, even on, sorry, but on HF, even on like 10 metres, I think there's nothing there, and you go to that.
Yes.
Streams of signals there and coming through, and amazing.
So, I think there's some options to talk Joe Taylor into adding single tone capability to JT65. The other thing is the single tone. There's a facility in JT4 to integrate a single tone over the full minute, and when you use that facility, it produces a graph like this, and you see that spike which stands out so well. That's the result of this tiny little bit of single tone here that you can hardly see on the waterfall. Yep. So there would also be an advantage if we could get Joe to add that single tone integration facility into JT65, and I'm sure that we'll be able to interested in some of these things, I hope.
In the fullness of time.
In the fullness of time, yes. Now, spreading of the signals, the detective story. This is
where we go.
Yeah, this drove me up the wall because
It's going to black and white now.
That's right.
Venetian blinds and
I started off working 5DK on 432, and everything was spot on. I went to 10 gigs and he said, "Oh, your signal's distorted, it's like rain scatters."
whoa, what's going on here?
So I said, "Well, have a look on the Bureau of Met radar and see if there's any rain." He says, "No, there's no rain, there might be some sea fog around." And I said, "Oh, Jesus, that's doing some dreadful stuff to my signal." So this is what a single tone looked like as I received it from 5DK. Now it's spread, this is on 10 gigs, it's spread over 200 hertz and it seems to have sidebands either side. And,
Rain bands.
and this sort of confused me. Now I brought with me a little, I think I've got it next to me, yes, a little GPS locked signal source. So I set up my GPS lock signal source. It unfortunately takes a few minutes before it gets properly locked. But when it settled down, I still had this broad spreading signal
In the receiving system.
in the receiving system, and I was only transmitting a couple of metres. So I was starting to think maybe it's not at 5DK's end, it's probably at my end that this is happening. So having a little GPS lock signal source is really valuable for sorting things out at 10 gigs. And this is what it looks like. It's got its own little gel cell. It's got a little GPS that only draws about 50 milliamps, and a VK3XDK DDS board. Yep. And it generates a frequency about 1,000 megs and enough harmonics to be heard at 10 gigs and 24 gigs. And Graham XDK actually programmed it up so I can have a switch where I switch between 10 gigs or 24 gigs.
Okay.
And it's got its own little GPS antenna on a piece of metal there, so that I can just put the whole thing in a box and like that. And it's really valuable to have out in the field, partly because you're essentially building a station every time you set up, and it's nice to know that it's actually working, particularly if you're doing aircraft scatter and you're waiting an hour for an aircraft to pass and nothing happens. It's good to know. So then I played around. I had really no logic to this, but I swapped the BNC connectors on the 2 ports from my GPS, one which fed the phase locking for the IC910 and the other which locked the 10 gig system. And my GPS source told me the problem had been fixed. I then called Colin 5DK and he said, "Oh, your signal's wonderful, it's all fixed, no spreading." So I said, okay, maybe just a bit of dirt in the BNC connector or something. And I felt I was all okay. A bit later on, I'm on 432. Now, on 432, because I used the other port, I had switched the IC910 just to its own internal oscillator. And David was listening to me on 432 and he's saying, "Oh, your signal's spread." And I thought, where's this damn spreading coming from? So he was seeing a signal like this. Here's the main signal on 432 and there's these bloody spikes coming, or bursts all coming out like this. Now, at the time I didn't know, because he just reported that I had a problem, and I thought, well, I know I fixed my problem, so it's not my end.
First mistake.
Now, David's very polite and, "Oh, I think there's a problem there, you know." So when I got home, David sent me some WAV files, and I saw this WAV file and I thought, oh, Jesus, what's causing this, damn? What's causing this? I still wasn't totally believing. And then the other David, 5KK, sent me a WAV file on 10 gigs. And he had an example of this.
Two sources.
And I was starting to think, geez, it must be at my end. What am I doing wrong? And I set up all my gear in the lounge room and I tested it and it was all spot on. Couldn't find it anywhere, and I thought, oh, must be something to do with the generator, when I use the generator in the field. So I set up the bloody generator on the balcony,
Kitchen table.
and that didn't help. And I was thinking, oh, I don't know what's going on. I'm going to have to. Must be the PLL in my 910's not locking or something. I had another 910. No. Was still all good. Well, I mean, even the original one was good by this time, so whatever it was had gone away. Then David 5KK sent me the file at 10 gigs, and it looked like this. This is a single tone.
Looks like a spiral.
Yeah. DNA.
And I thought, what the hell's happening? Now, I look back at this, and I've marked in blue here
Oh, the periodicity.
the periodicity, and then I noticed there was another one, another period with a slightly different shape in here. Now, these were 1.3 seconds apart, and these were 1.4 seconds apart. I was thinking, how's my PLL causing two different things, or my generator noise, and why is it 1.3 seconds, not related to 50 hertz, or...
Yeah, and it's pretty regular as well.
And it's very regular, so what's going on? And then when you look at it 10 gigs, it turns out to be 1.4, so it's the same period as at least one of these things. And 10 gigs, it seems to go out both sides, and it's different in nature, but it's obviously the same.
Same interference
It's
or
the same interfering. So the penny dropped.
Oh, it's the windmills.
The windmills!
Oh, I love it.
Did you ring up Aurora?
You're shooting through a modulator.
Well, I wasn't. I mean, I was a long way. There was a few close windmills, but I wasn't really being any
Through them.
through the ones that were close.
Yeah, what about air turbulence or something like that?
Well, I then thought, I'm just going to have to work out all these bearings and where these wind generators actually are. And
You avoid them.
then here was the bearing to 38Z, and there was a wind generator here, 50 metres off the path, and another one here, 45 metres off the path. And I looked up the specs for the wind generators. They had a 90 metre rotor, which really said, I'm not really going to be going through them. I thought, well, maybe the Fresnel zone clearance extends that a bit. I did the Fresnel zone calculations. The first Fresnel zone was only a couple more metres at that sort of distance, so that didn't look good. Then I looked at what it was to 5KK, and there was a nice close windmill, 84 metres off the path. But when I calculated the angular difference, it was much wider than the beam width of my antenna, so it couldn't be. This one, yeah, it was at least within my beam width, but it was still outside the first Fresnel zone, and it was over 3 kilometres away. So I was still not totally convinced. So I then did a little bit more research on the wind generators. Now, turns out that they're 90 metre diameter, 3 blades. They're what's called a double-fed induction generator, and they're variable speed, but they produce 50 hertz output. Variable speed and produce 50 hertz output. Now, apparently, and I don't understand this, but somebody might, if you feed 50 hertz into the rotor,
It locks.
it locks the thing, at 50 hertz,
It's
even
like-
though the generator is varying
No,
its...
it's like connecting a generator to the grid.
Agreed. It's got to be in sync.
And the grid...
But it's not quite that, because the generator, according to what I read on the web, can actually vary plus or minus 30% and remain on frequency on the output. So the
Yeah,
speed...
but do they do that electronically or mechanically?
don't know, but what it's saying is the speed actually does vary.
Okay.
So that was useful to know because I'd seen these period variations.
Yeah.
I then found out it had a 100 step-up gearbox,
Okay.
and when you work it out with 3 blades and a 100 step-up gearbox, it says for 50 hertz in the
Guess what?
centre, it should be 1.5 seconds that each one of these blades bloody goes past the signal.
Mm.
And with the 30% range, that means anywhere between 1.05 and 1.95. So the sort of variations we were getting from 1.3, 1.4 all made sense. Still very hard to believe that a signal that's I'm transmitting on 10 gigs over 1,000 kilometres to 5 kk and getting this massive variation for a wind generator that's 3.5 kilometres away. So
Okay.
When you're grasping at straws,
then I went and looked back on my results from Derek back on the 5th,
original. Yeah.
on the 5th of January. And when I looked at them very carefully, look at this pattern out to
5 seconds.
at 1.5 seconds.
So you were getting the sign.
And then when I looked at Derek, there's a wind generator sitting, well, it's actually only 0.14 degrees off the path.
But still, what distance are we talking about?
3.5 kilometres. So, my conclusion about this is the wind generator probably actually got the world record signal a few microseconds before I did and was able to decode it
That's your idea.
and got it first.
Oh, there you go. Oh,
So-
I can feel a dipstick talk coming on here.
So, that is the detective story.
I love it.
And I'm pretty sure that it's a wind generator. Now, Charlie and Petra, who are on
Yep.
they have been able to confirm this because they have got a whole lot of results on 10 gigs where they were driving around listening to a beacon, and every time they went past a wind generator, they got all these
Variations.
together. Now, they're only they're talking about a beacon that was sort of 100 kilometres or 80 kilometres or something, but it's pretty clear that wind generators seem to be able to cause a lot more stuff to your signal than you would believe from the size of the blades or anything else. Now, admittedly, when you actually measure them, the scattered signal is typically 10 to 20 dB down, which is a fair way down. I have a feeling that when I was beaming to 5 kk and 5 and 3HZ, I was beaming up a hill, so the direct signal probably wasn't as strong as it would have been if I had a clear takeoff, and yet the signal off the wind generators was sort of line of sight to me.
Yes.
And so it got an advantage. But that certainly wasn't the case when I was beaming to Derry because I could see the water.
Yeah.
Admittedly, the actual wind generator signal is much weaker to Derry. So, but from looking at the different distances the wind generators are, it seems to be that the spreading is a function of how far the generator is off the path. So essentially, if the generator is off the path length is increased. If the generator is right on it, the path like it was with 5kk, you get it off both sides. Spreading at 10 gigs is typically 10 to 30 hertz, even up to 50 hertz. Typically 10 to 20 dB down on the main signal. If it is always only 10 to 20 dB down, it is probably not a problem for JT65A. But I'm saying keep JT4 as a backup, because at least it can cope with several hundred hertz of spreading. So the conclusions are the Hepburn charts are a useful indicator, but they don't seem to have the resolution to show the effects of cold fronts and troughs. Ducting doesn't generally result in any spreading, and so narrow bandwidth modes like JT65A are worth exploring. And be wary of tilting at windmills. Now, I've heard the phrase tilting at windmills a lot, but I'm not a reader of English literature, so I didn't actually know what it meant. And I looked it up, and it is an English idiom which means attacking imaginary enemies. And apparently this Don Quixote, and it who was going to slay the windmills or something. He thought, well, giants. But when you think about it, attacking imaginary enemies, I had spent several days trying to find out where this bloody spreading had come, and it was an imaginary enemy. So
I love it.
be wary of tilting at windmills. Thank you.
Is there any effect of prop aircraft?
I think the trouble is prop aircraft don't stay in front of you for long enough till you see the period and stuff like that. As well as that, the props are not anything like the size of a 90 metre windmill, but maybe.
Just turn that up. I've just asked for any questions on streaming.
On streaming.
We do have a few more on here. There's 2 DAG, 3 PF, 5 KBJ, and there were a few people that came and went.
So we've got something like probably seen about 20 overall.
Yeah.
So we've had about 20 streaming viewers. That's terrific. Well, we might just open it up for comments on the local VHF. Dave's just 3HZ. Yes.
What's the GPS in the test generator?
It's a Firefly 1, which is probably just a TCXO, not as good as one would like, but basically as its only purpose is to establish that everything is all right, we get away with it. I think the lights that are now available would work pretty well in the test generator.
Okay, cool. Any other questions on either?
On VHF, are we listening to VHF?
Yeah. Any RF or streaming?
No? Well.
VK702C, VK7MO dual. Thank you very much. Very interesting. And just wondering if you could use the wind farms around Australia as a sort of repeater, one repeater to the other. VK7, OTC, VK7TR, and that was a pure pro.
Thank you, Tom. Now, I'm not sure that I can answer that question, so we'll put it over to Steve, VK700. Go ahead, Steve.
Sorry, I didn't hear Tom's question because I was talking at the same time. Sorry, Tom. But I did have a question. The interference from the windmills, do you think that was a reflection back into your own dish and therefore being retransmitted by your dish into the path? Or was it a loss of signal? How do you interpret that information?
It's a good question, Steve, and I don't really know. Originally I thought it was just the blocking of the signal. Well, if it blocks it, of course, there wouldn't be anything going off to the side, so it's not that. I can only think it is something like, because the wind generators are in line, it's not reflections as such, because you can't reflect from one side of a mirror to the other side of a mirror. I can only think it's knife edge refraction or diffraction, knife edge diffraction off the edge of the blades, and the fact that the further the blades, the generator is off to the side, increases the Doppler. It's consistent with a slightly longer path. So the signal is actually being, it's coming from the wind generator, and knife edge diffraction is the only conclusion I can draw. Now, as far as Tom's question, Tom's question was, can we use multiple wind farms as repeaters? I don't have an answer to that, so I'm avoiding Tom's question, Steve. But I'll just put it back to you in case you have any further comments, Steve.
Okay. And from Charlie,
Yes.
we put some windmills or videos of windmills on 10 gigs on YouTube. Search for DB0ANU.
That's right. Yes, I should have mentioned Charlie's wind generator videos, which shows the sort of scattering he was getting. I know there's going to be some interest in this talk, and I'm looking at Justin, where it might be possible that we can put this talk
On YouTube.
Yep. And the earlier one.
Yeah, get to that one.
As well as that, unfortunately, a lot of the slides I showed probably didn't have enough detail to were too finely structured to show up on the TV. So we might get Justin to put the actual PowerPoint presentations up, and we could also put a reference to Charlie's YouTube videos. So we could have a whole package on the mysteries of 10 gig propagation or something.
Another question, VK3OF. What is the beam width of the dish used in those tests?
Right. Mine is about 3 degrees, and this is on 10 gigs. And both David 5KK and Derek 6DZ would have probably about 4 degrees beam width total, so plus or minus 2 degrees and plus or minus 1.5. On 432, my beam width, obviously with I think a 22 element Yagi would have been much wider, so there's not much question that on 432 the windmills were well and truly within the beam width, but not actually quite in line with where the signal was going. So all of that does support the view that there was not only knife edge diffraction, but the knife edge diffraction was able to bring the signal back to my station. Now that could be because the shape of the blades, I mean, knife edge diffraction, as far as I'm aware of it, is always at right angles to the knife edge, but maybe the slope of the blades in some way.
Because it's always the same angle that it goes in at, it comes out.
So, I mean, if you think about it that way, the chances that you'd ever repeat this just seems to be 0, but the fact is...
but you proved that wrong.
That's right. We did it on 2 days, 2 separate days, with different windmills in different directions and so forth. So a lot of it is unbelievable, but there's so many pointers that make sense that I can't think of another reason for it.
Is there some sort of effect that is actually wider than the blade of the windmill? Because the fact that you were nowhere near you were not beaming through them,
Yeah,
and yet they were affecting the signal.
yeah.
But then the effect of the whatever the blade does with the air as it cuts the air or whatever has to be bigger than
Yeah.
90 metres.
But if it was if it was an effect on the air, you wouldn't think it'd be so regular and I mean,
Yeah,
and so sharp.
I don't know.
But you're right. We shouldn't. I'm doing it again. I didn't trust David when he told me it was there, and now I'm not trusting you when you know. I've got to accept inputs from everybody to understand this problem.
It's interesting. It's fascinating, though.
All right.
Absolutely.
So I think we've probably concluded all the questions, have we?
I think we might have. So.
Okay, just in case Steve had another comment, I'll just go back to Steve, VK7MO. No? All right, well, thank you all for listening, and all our streaming viewers.
Definitely.
This is probably the best audience that Reese has had, so thank you.
For ATV, definitely. Thanks, Rex. Thank you very much. Let's go. And the studio audience goes berserk.